Right, success criteria 8 is about solving a polynomial for a given value. So to do these may come in a lot of weird and wonderful combinations, but basically what we're looking at is a polynomial on the left-hand side equaling something else on the right-hand side. So this may be given to you like this as a number, like it is here, or other things could happen, but we'll go through this first. So for this, we've got x squared plus x minus 6 is our polynomial. We want to find out when that polynomial equals -1. Well, what we do is we take this -1 and bring it across the other side. So we end up with x squared plus x minus 5. Sorry, and now that equals 0. And then from there, we'll either factorise or apply the quadratic equation or whatever the case may be to solve this. So we'll have that. Now this looks like it's not going to factorise easily, so I'll just say -1 plus or minus the square root of 1 minus 4 times 5 over 2. So I'll say -1 plus or minus the square root of, it's the -5, square root of 21 over 2. So -1 over 2 plus square root of 21 over 2, or -1 over 2 minus the square root of 21 over 2. So that's my solutions there. So basically what we're trying to do, we want to make it so we want to let our equation equal 0 because that's what we know, that's what we're good at, and then we solve for that. So if it was a cubic, so we had x cubed plus 5 equals to -1. Well, like we had here exactly. Well, then we do the same thing. We bring that over to the other side, so we become x cubed plus 6 equals 0, and then solve for x. If it's a more complicated thing, where we've got x cubed, or no, we're going to do x cubed. If we've got x to the power of 5 plus 3x to the power of 4 plus 2x squared equals -1. Well, we bring that over to the other side and becomes x to the power of 5 plus 3x to the power of 4 plus 2x squared plus 1 equals 0. And then from there, we use whatever techniques we need. So we may use the factor theorem, FT should be, the factor theorem, remainder theorem, whatever the case may be, and long division to solve for any factors, and then from there find any solutions. So that's what we do. Now, that may be expressed like this, where we just have an equation equals some value. We may be told the same thing of f of x equals some equation, and g of x equals some other equation. When do f of x and g of x equal? It may be expressed as where do the two graphs intersect. So where does f of x and g of x intersect? G of x may just be a number 5. F of x may be something to the power of 12. Doesn't matter. We still go through things the same way. But like I said, with a quadratic, or they're easy to factor, or you can use the quadratic formula. If it's a cubic or a quintic or whatever, the 12ic, we just let it equal 0, and then from there we just apply long division.